warm applause for Moritz.
Yes, let's try this. It works, oh my God. Oh, I forgot something, just a second. Because I have notes. And I wouldn't say that these are absolutely necessary, but at least they help me along the way. All right. There we go. There we are. Okay. All right. Hello, everyone. How's it going? I'm just going to cut right to the chase because I think we're already late on time and large introduction shouldn't be necessary. I'm going to be talking about what TDD is to infrastructure and why we might be not doing it and why we maybe should be doing it. And I kind of lean this on the premise of playing port authority. So port authority is obviously a certain checkpoint within a larger container context where people are loading or offloading after a manifest containers. And doing TDD for containers or doing TDD via development for infrastructure is kind of the same thing. You're kind of checking whether your expectation is met within the environment that you're trying to deploy in before you're actually doing it. So in a sense, it is kind of like playing port authority. My name is Moritz Heiber. I'm working for Thoughtworks. My actual title is DevOps Birth Assistant, and Birth Assistant in the sense that I don't know if you don't know the word birth assistant, actually is the male form of a midwife. I call myself a birth assistant because that's what I usually do for clients. Every larger and sometimes even smaller software hardware project that I do is precious to everyone at the client side. So it's be it product managers, be it developers, engineers, everyone alike. And I'm essentially bringing their software babies into the world, software and hardware babies. I care for them for some time, and then I try to hand them over to whoever's responsible. That's what my title is all about. I usually do DevOps consulting. I do continuous delivery consulting. Thoughtworks itself is famous for Agile and microservices. That's the whole packet that I usually am confronted with whenever I'm at the client side. But let's talk about why I'm here today. So these days, a lot of things are getting built inside with container technology inside containers. Docker, in this sense, is a prime contender in this space. It's used by a lot of people. It's versatile. It's portable. It's supposed to be used for isolation purposes as well. One can argue if that's the right thing or not. And it enables them to develop very complex interconnected applications faster and makes it possible to deploy them in a more efficient way and with little effort. So Docker, in a sense, can be seen as the manifestation of what we call infrastructure as code, because that's what a Docker file essentially is. And usually contains a set of instructions, which then provisions an environment within the container, which is then meant for running software. So, however, as much as we usually follow TDD principles, so test-driven development with regular software these days, which is pretty common, when it comes to infrastructure and containers, in particular in this case, many people still have the approach of plug and pray, essentially. So you develop an app, you put it inside a container, you just see whether it runs. If it doesn't, then you just reiterate. And you just want to try out some changes, and usually what you end up with is some kind of error or fault, or it doesn't work at all, and you just roll back or use other mitigation technology in order to actually address the issue. And that, while it might be appropriate for a single developer on a laptop, right, that's something that you might be doing each and every day. Once you actually have to write code for containers themselves, or as we just seen for container orchestration platforms, that within a team context even, that might become an issue sooner or later, because then the plug and pray approach will most likely result in downtime, or might even, have an effect on customers. And that's not necessarily something that you really want to have an impact on. So I was asking myself a question like about 2 years ago, 3 years ago, which was, why don't we apply the same principles, since we have infrastructure as code already, to infrastructure code that we already apply to regular software code? So why don't we go over these infrastructure as code methods and actually apply unit tests and functional tests and integration tests before we're actually starting to deploy anything into an environment which has direct customer impact? And in that case, we could verify immediately by running our tests that you were on the right track. You could verify your expectations upon not only your code in the software that you write, but also in your infrastructure. So if we go the first step, this would be something that you write. This is a particular framework called RSpec, and it's a behavior-driven development framework. It's essentially a language to describe what your expectation is for the code that you're writing. I've chosen RSpec and Ruby for a reason here. Some people might not be familiar with it. It's not going to be an issue, I promise you that. So in a sense, what we're describing here is you're writing your test with TDD principles first, and later on you're resolving the test while writing the software that actually does the thing that you wanted to do. In this case, it's FizzBuzz. I'm not going to bore you with the details. You can look it up online. There are a million gazillion implementations of FizzBuzz. So, but what this function is supposed to do is it should give you back fizz whenever you actually input 3. That would be the test that you write in order to implement your software version later. How would this look if you wanted to do this if you wanted to apply this to infrastructure? So what you could do is you could use a framework which is based on RSpec. That's why I used it in the beginning, which is called ServerSpec. So you can basically test drive your container in the same fashion that you would test drive any single class or any single unit within your application. This framework, ServerSpec, is based on RSpec and spec infra, which is essentially a layer around ServerSpec, and it's very lightweight, and you can do full test-driven development with it. It basically, this what you see up here is a test which essentially verifies that within a certain environment, be it a container or be it any other environment that you want to test this in, the package Ruby is installed. So let's take a look at some of the details that you see up here. So step by step, this is the first step. So essentially what you're doing in the beginning is, okay, you're telling it, hey, this is where you should look for whatever code you want to run against this test. So essentially what I'm telling it is, I have a Docker file, and if you want to run this test, use the Docker file. Then I'm actually setting this option within the ServerSpec test. I'm telling him, hey, this is the ID of the container that you should spin up and that you should use for a test. And then I'm, in plain English, essentially, telling it, it should be installed. So it is the context within the actual test. That's why this expect clause that you see down there is just the package that I want to actually verify. Now, let's take a look how this actually runs. I have this prepared. Just have to switch my terminal and make it a little bigger because otherwise you won't see anything. Let's see. All right, there we go. Now, I hope this is readable. I think this is better, right? Can everybody read this okay? Okay, cool. Awesome. So I have written a little convenience script around the commands that you just saw. So if we switch back to this is essentially just installing a bundle, which is the a package manager within Ruby, which installs a couple of dependencies. Take it like NPM or any other package manager that you know. And then it uses that bundle to execute the test that you just saw. So let's actually run that test and see what it makes. So what I'm going to do is right now, I think I'm on the wrong branch, because in this branch this is already implemented. So I'm going to check out the other branch, and then I'm going to run the first test. So what this is doing in the background now is actually building the image that you saw before, or running the test against a non-existing image, and is then running the actual expectation that you saw before in the test. So right now this is failing, obviously, because we haven't written any code yet. There's no Docker file that we can actually inspect. It's empty. So what do we actually have to do in order to implement this then? If we go one step further, this will be essentially the implementation. So you prepare a Docker file, which in this case comes from Alpine, which is an officially supported Docker Inc. image, by the way, right now. It's just 2 megabytes. It's a pretty good foundation for pretty much anything these days, except for some things that use weird glibc functions. And all it does in this case is install one single package, and that's Ruby. The project structure in itself, so if you take a look at what the project looks right now, it has a Docker file, it has the test, And this is the expected folder structure when you look at server spec. So it's much akin to our spec if you're familiar with it already. Otherwise, this might be new to you, but it's pretty much easy to understand. It's just a spec folder, then there's a spec helper, which does all the things for all the different tests at the same time. And you have the individual tests in individual directories. So if we actually take a look at some of the files that are not necessarily pertaining to the test, one of the things that I mentioned before was bundler. Bundler uses something called a gem file to know which packages it needs to install. In this case, we're using rake. For some of the tasks in between, we're using server spec and using the Docker API because we want to communicate with containers in this case. And the second thing is, I mentioned this already, is the spec helper. This is kind of the setup instance for all the tests that you're running, because this doesn't necessarily have to be just one single test, can be multiple tests. So in this case, we're requiring all the packages that we installed previously, and we're setting the backend to Docker because that's where we want to run our tests. And the OS family inside the container usually is auto detected, but we're just making sure that the auto detection actually doesn't go wrong, and we know that it's going to be Alpine, so we're just going to use Alpine for this. So now let's jump back to the actual example that we had before, and actually go back to the master and see whether if we've written that Docker file before, whether it actually completes and how it looks. So I'm just going to run the test again. And right now you'll see the package actually works. Docker file is complete. It actually does what we're expecting it to do. We can run this test each and every time. It'll go green if the Ruby package is installed. If it's not, then it'll go red. All right. So let's go for something a little bit more complicated. Just a little tiny bit. So let's implement a very, very simple web service, because obviously you don't want to just install packages. You might also want to install applications. This is a very small, very, very small Ruby web service. It uses Sinatra, which is a very bare bones HTTP framework for Ruby. And the only thing it does is it gives out sample web service on the root route. So nothing really fancy. The only thing is, now we don't just want to make sure that the Ruby package is installed. We also want to make sure that this actually is running whenever we run the container. So how does the test actually look? This is what it looks like. So again, setup at the beginning, then we're describing the second example that we're actually addressing right here. We're using a second Docker image, and then we're doing two different things. So the first thing is, this web server will be running on a certain port that is going to carry our web application. It's going to be port 4567. And the second part is, it should actually, if we query it, it should actually respond with the definition that we have had in our web application. Once both of these criteria are met, the tests are green. So if we jump back to our test, let's go back to the failing branch and run the second test. Now this will obviously not complete because again we haven't written our code yet, and that's why we're going to get two failing tests. It's building the images in the background right now because it's forced to rebuild them each and every time just for coherence's sake. And if we scroll up, you can see here there's nothing listening after a short timeout. Obviously, our spec fails here. And the output that we get for using curl within the instance is also 0 because there's nothing actually giving anything back. So, and now let's go back to the actual to the presentation and take a look at the implementation. So this will be the code that you write in order to satisfy the test that we've just run. So we're basically saying, again, Alpine, just install a couple more packages, which you could also test for, just for the sake of brevity, I've excluded those. So we want to install Ruby again, because it's a Ruby service that we're running. Ruby JSON as well, because we want to actually pass data. And this little caveat, which is that we're installing curl, because we're actually running this test, this curl, this actually integrity test of giving back a string inside the container. You could run it outside, but that would mean you'd have to reset the handler and such. It's a little bit more complicated. So for now, the curl is only used for the test itself. And then, in the end, we're installing Sinatra, and we're actually running the web service that you've seen before, which gives this sample web service, which gives back the sample web service. So if we go back to the command line, and we actually check out the master again, I'm just going to run the second test. Once we've had this implementation of the Docker file, and we're running our test again, you'll see that now the two checks should be passing exactly here. So now if we run a container, something will be listening on port 4567, and it actually responds with sample web service. That's actually a huge step, because we have not only verified that the container itself is a valid Ruby environment, but we can actually run the app that we've written before within the container, and it'll run each and every time. We can verify that it'll run. If there's something in the app that changes, and it no longer conforms to the test, and the test will break, and you will know that you will have to adjust some certain things, either within the container or with the app. So this is a pretty simple example, and people will say, okay, this doesn't really make any sense for me because I have more complicated applications. Well, the cool thing is you have all the power of Ruby at your disposal. Ruby is a fully functional programming language, essentially. It is a scripting language in a sense, but there's a lot of functionality that is built in or can be attributed to packages that you can pull in. So what you can use in this instance is also you can use Docker Compose. So if you have an application that actually consists of 5 different containers, you can test drive this application using server spec as well. So let's actually compose a web service, again, a very simple web service, but still a more complicated one, which not only gives you a web service, but also reads a value that you put onto a website from a dynamic console instance. So what you're doing here, you're not only starting up a web service, you're reading a dynamic value from a key value store and then putting it on a website. And for that to actually make sense, you would have to have 2 containers running. You have to have a Docker Compose YAML file. So that basically gives you an idea of which services are going to be running within this testing environment. In this case, the official console image, which is available from a Docker Hub, with console running in dev mode. And you have the Docker file, which corresponds to the third example here, which is getting built on the fly whenever this test is getting run. So it's a pretty simple Docker Compose file. Now, let's actually test this. So the thing is, obviously, the complexity that you can use with server spec is limited when it comes to handling containers, and it's also not something that server spec necessarily was written to do. So what we do now is actually, before we write the tests, we make sure that the whole environment that Docker Compose is running within is set up. So in this case, we bring up all of the instances within the environment, and then we actually supply a value within the console KV container and make sure that it's available to be read by the application. And afterwards, we actually just tear down the containers again and make sure they're no longer on the system. So each and every time we instantiate a whole new environment, we test in it, and then we tear it down again. And for this to work, before we had Docker image, now we're using Docker container as a configuration variable. We're telling it essentially, this has been started outside of your scope. Just look for it within the Docker environment, and if you find it, you can run your tests in it. All right. So this is what the whole teardown and bring up thing looks like essentially for the test. And this is what the actual test looks like. So you're essentially saying, again, there are some tests missing that have been run previously, but you can add them in later if you wanted to. So what this says is essentially is, if you're accessing the web service that we've put into the container before, the value that you get back should be coming from the key value store. If there's no key value store, if there's nothing in the key value store, it should not be giving anything back. So let's actually run this, switch back to the failing branch, and actually run the third test. So this is actually showing us right now what it's doing. So it's rebuilding some of the containers because we're actually not using server spec to build the container, but we're actually using Docker Compose. So this is the output of Docker Compose. And we're running a single test, which now obviously is failing because it wasn't able to create anything. There's no definition for it. And that's what we're stuck with. All right. So let's switch back to the actual implementation. This is the Docker file that contains the same thing. It's essentially quite the same. It's just that we are running some things differently. But in a sense, you can see that it hasn't really changed all that much. So it runs the third web server, and And that's about it. So if we actually take a look now into the test, actually check out the master again, and run a third test. It'll actually pull up our console instance. I hope this works right now. This is kind of the wonky part of the presentation. It pulls up a console instance again. It installs packages that it needs in order to access the key value store from the container to supply the value to the web server. And now it's actually running the test. And I hope it's going to finish in time. Come on, I believe in you. Takes a little bit longer. There we go. So what we've done right now is we've verified that not only can our web service talk to a console key value store, it can also fetch the values dynamically. And if we want that value to be of a certain kind, we can. We've verified this through our tests. This gives us much more confidence in what we're doing with infrastructure, and especially containers, than maybe it was before. It's not a plug-and-pray approach anymore. It's conscious testing. Now, I've showed you a couple of resource definitions before, but obviously there are a lot more, a lot more. So this is just the tip of the iceberg. You can look into Docker containers. What you can do also is you can look onto Windows machines. You can use SSH to actually verify VMs. What we're using it for usually is also we are verifying AMIs. So if you build an AMI, you run a test afterwards because you want to make sure that it actually conforms to your expectations. There are a lot of different resources that you can use. Verify users, verify groups. You can verify that the process is actually running once the container is started up. You can verify whether the port is open. That can be TCP, UDP, or any other protocol, or whether it responds with a certain datagram. The cool thing is that everything that you do is, again, a Ruby class, which means you can also have complex applications or even complex classes behind it. In this case, ServerSpec has native support for verifying certificates. So you can actually verify whether a certificate you've fetched for the certain container that you're building or that you've built into your container actually is valid, or whether the CA certificate is valid. You can test it against certain containers. You can test it against certain images. There are many other resources that you can find. I've mentioned this already. There are also a lot of different backends. So I've shown you the Docker backend. There's also the SSH backend, which has numerous abilities to basically use SSH to SSH into VMs, onto running instances, to continuously verify operations. There's the exec backend, which lets you access resources on the machine that you're running the test on. So for example, verifying locally whether or not a certain instance has come up the right way. And there's also, for the Windows lovers underused, this WinRM support, which means you can actually do this on Windows as well, since Ruby runs on Windows. I think that's pretty brilliant. Now, this presentation itself you can find on GitHub. It's up there with all the code that I've used today, so you can actually go through the different steps on your own. You can verify whether they work or not, and see whether you can actually dig into this. ServerSpec and the spec infra libraries are the ones that I use today for this presentation, and rspec wait is something that is pertaining to port openings, and which basically makes it more dynamic in the sense that you can run your tests and wait for certain conditions to be true. All right, that's the end of my presentation. You can find me on Mastodon. If you don't know what Mastodon is, by the way, it's a new social network, decentralized, federated. It's the new kid on the block, essentially, and I'm on it as well. Or you can write me an email or hit me up on my website, and I thank you for your time. And I think I have time for questions, even, if that's okay.
Yes. So are there any questions for Moritz?
I think a mic is coming to you.
Thank you. I have one question. So in your example, you're just simulating BDD for containers, right? And if we want to run unit tests, we need to run them inside Docker, right?
Well, it depends on which layer you're trying to test, right? So if you want to use ServerSpec for that, that's a BDD framework, so you necessarily won't be able to run unit tests with it directly, but you could use ServerSpec to run unit tests at the right time. So you could basically say, take that Docker file, put it into a third-party command, or put it to a certain class that you've written, and make sure it actually verifies, or the unit itself, the Docker file unit actually verifies.
Yeah, maybe I need to rephrase it.
Sure,
So,
go ahead.
So yeah, in your example, you are testing the Docker file itself, the packages, and the Docker file exposes ports, and that application inside the image inside the container works, right? And for instance, we also have an application. We have unit tests for application itself, for our services, models, controls, and the other stuff, right? But we cannot run it as a part of this container testing, right? So we need to run them inside the container. So it leads that to the point when we need to run one suite for testing containers.
Yes.
And one suite for unit tests.
Yes.
Okay.
So for me, that would be separation of concerns, essentially. For me, unit test for your application in whatever language it's written should be something different from your expectations that you have for an environment where the application is running in. As I said before, it's a flexible language. You could run your unit tests, your integration tests for your applications from within server spec if you want to. I guess I wouldn't recommend it. It could be, so if you're thinking in terms of continuous delivery, for example, you would have this as a kind of step within your pipeline, which gets executed one by one after another. And I could see this definitely as something that you put into the right location within that pipeline. So hope that answers your question.
Yeah, thanks. I was thinking the same, just want to be sure that I get it.
So it's not an all-knowing framework. It's one piece of the puzzle.
Yeah, thanks.
More questions? Nope.
All right.
Okay.
Thank you very much.